We'll talk about the REST-based SOA implementation done by the United States Coast Guard and some of the specific things that they did and some of the implementation details. That'll be a slightly smaller talk for about 40 minutes. And then there'll be a third wrap-up talk by Jason. So without any further ado, I think we should just get started here.
Well, thank you very much. Well, good. It's great to be here in Singapore. My name is Jason Bloomberg. I'm president of ZapThink, which is now a division of Dovell Technologies. Dovell is a government contractor in the US, and they acquired ZapThink in the middle of last year, so now I'm a member of a larger firm. But ZapThink's been around for over 10 years. We were known as service-oriented architecture thought leaders, working with enterprise practitioners around the world, running our 4-day licensed ZapThink architect course. And now we're rolling out a new 2-day cloud computing course as well. And in fact, I'm running it here in Singapore tomorrow and the next day. So a little short notice for you folks, but I'll be running it in Singapore and then India in a couple of weeks, but it's taking it all over the world. So this morning I'm starting off with talk about REST-based SOA. So how many people here know what REST is? Oh, nobody. Okay, one, two. Okay. Well, don't worry, we'll start at the very beginning. How many people here know what SOA is, service-oriented architecture? Okay, got a few more volunteers for that one. That's good. Okay, well, let's start with a definition of REST. So what is REST? Well, it stands for representational state transfer. And it's a mouthful, right? It's a long name, but there's a reason why it's called that. We'll talk about the state part of the story, and we'll talk about representations. So by the end, you'll understand why it's called that. So it's essentially an architectural style for building distributed hypermedia applications, such as the World Wide Web. So we'll talk about what hypermedia is as well, but essentially you can think of it as building applications that take advantage of the best practices of the World Wide Web itself. So if you look at the web, what do you see? Well, it's immense. Right? It continues to grow. No one person or organization is in charge, and it's enormously resilient, right? I mean, sometimes you have bad links, but overall the whole thing keeps working, right? It's very hard to take the web down, and it's infinitely scalable, right? It keeps growing, and we don't even know how big it is. That's how big it is. So the idea is, well, let's look at the web and let's see if we can gather some architectural principles from the web that we can use in our own organizations to build applications that have the same properties. So who came up with REST? Well, this fellow here, Roy Fielding, he was one of the original creators of the HTTP specification, and he invented REST as part of his doctoral dissertation in 2000. And so he is essentially the progenitor of REST. So he established these principles. So if you're familiar with REST, and I guess only a few people are, it's broadly understood to be an HTTP-specific way of addressing resources on a network. But there's some myths, some things that people believe about REST that aren't strictly speaking true. For example, it doesn't necessarily depend upon HTTP, right? You could use other protocols. There's nothing specific to HTTP that requires that particular protocol. You could use other protocols if you wanted to, Jabber protocol, XMPP, or some others. But for all practical purposes, virtually all REST-based deployments are HTTP-based. So the question there is, in your organization, well, do you have HTTP everywhere? Maybe, maybe not. Is REST appropriate in those parts of your organization that have other transport protocols? Well, possibly, but in general, REST-based tooling is HTTP specific. Another question, and this comes up often in discussions of REST-based SOA, is that do you have to choose between REST or web services? And the answer there is actually no. In fact, there's a REST binding for WSDL in WSDL version 2, so you could do REST-based web services if you wanted. And one of the things we'll be talking about is how to do REST-based SOA with or without web services, right? It's really not a question of choosing REST versus web services, but REST is an alternative to SOAP, which is the transport protocol specific to web services, but you could pick different transport protocols as well. And then there's also the question of security. If you think about REST being HTTP specific, then you might say, well, are we going to use SSL then to secure it, right? We use SSL for securing HTTP interactions. And there's some problems with that, right? SSL is point-to-point, it's transport level security, so you can't secure parts of messages, and if you have messages going over multiple endpoints, then you have problems with lack of security after it crosses one endpoint. But as it turns out, there are other security approaches that you can use with REST that use other technologies in addition to SSL. So the security problems can be solved as well, even though in many cases REST deployments use SSL, and that limits the flexibility of your security. But that's not necessarily the case. Okay, so when we talk about REST, there's a number of new terms that are part of the REST language. And if you talk to a RESTifarian, somebody who's really excited about REST, they'll be using this terminology. So let's define some terms. So first of all, REST talks about a resource, and a resource is essentially some capability on a server. So it's an abstraction of a server capability. So you can think of it as something your server does for you. So it could be a PHP script or some other code on a server that can generate web pages or other representations. So what's next term is a URI, Uniform Resource Indicator, and that's a string or identifier. That's a string that identifies a resource on a network. So it could be a URL, Uniform Resource Locator, or a URN, Uniform Resource Name. But essentially it's a string that identifies the resource on the network. So if you want to find it, you can use the URL. So that word representation is essentially what the resource gives you. So you can think of it as a web page, right? If you have a PHP script and your browser hits the server, it gives you back a web page. The web page is the representation of the resource, which is that PHP script. But it could be a web page, an HTML file, could be an XML file, could be a video file, could be a vector file, could be a JSON file, right? There are many different types of representations. And then the term hypermedia, right? REST is about building hypermedia applications. So what is hypermedia? Well, it's essentially an update of the term hypertext, right? Where hypertext was essentially a set of web pages with hyperlinks that link from one to the other. Only now it's not just web pages, it could be any type of media. So any type of media interconnected via hyperlinks is essentially what we call hypermedia. So again, it's still just a glorified website in that sense. Okay, so what is a resource? Well, it's anything you give a URI to, right? So if you can find it on the network, you can think of it as a resource. So it could be static or dynamic web pages, it could be documents or images or rich media of various sorts. So it could be API calls. You could have a web service be a resource as well. It's basically anything the server can do for you is a resource. So when we talk about a uniform interface, this is one of the key differentiators of REST. And this is where a lot of people get stuck because they see this as being central to REST. And it's important, but it's not the whole story. Right? The idea with a uniform interface is that we have 4 operations, and that's everything that a client can do to interact with a server. And they're get, post, put, and delete. So get and post are familiar from HTTP, right? If we have a web page and it's interacting with a web server, it can either get a web page or it can post a web form. And if you've worked in the web, these are very familiar. Well, put and delete are also part of the HTTP spec, and you can generalize these to other protocols other than HTTP as well. So the idea here is that these are the operations you get. And everybody agrees that these are the operations you get. So all you have to do to program your resource is make sure that you're responding to these 4 operations the way the client expects. So contrast that to web services where you define your operations any way you like, and now there has to be some way to discover the operations, and you have to go fetch your WSDL file from a repository somewhere to figure out what the server is going to do for you. Well, here it's get, post, put, or delete. Right? We don't have to look anywhere to find that out. Those are the 4 operations. That's all we get. So it's a uniform interface for all interactions between clients and servers. So here's an example of how this sort of thing works. Because one of the questions we often get is, well, what's the difference between put and post? Right? Post is familiar. If we have a web form, we want to post information to the website, we want to update some resource, we can use post. But actually, that's more of what put is for, right? Post is more for initializing a resource, and put is more for updating a resource. So here's a problem, right? The first example is if I wanted to use put to create or to update a resource, then I do put/resource, and then I put the ID, some sort of unique identifier for the resource. The problem here is that if I don't know what that ID is ahead of time, and I'm trying to create it with the put operation, then I may have picked some ID that is already in use, and I could have a problem that way. So instead, I want to post to the resource without specifying an ID, and that tells the server, hey, create a new resource, and create a new ID for me, because now I want to have some particular instance of that resource to work with. And the server responds with a 201, that's an HTTP response code, saying, yes, okay, I created this resource, and it returns the URI of that resource with the ID that the server has now created for this particular instance. So the idea is now the client can now work with that particular resource because it has that information in a hyperlink from the server. And that's an important part of the story, right? That location actually is part of a hyperlink. Okay. So URIs can be either uniform resource locators. We're all familiar with those from the web, right? Those actually specify the resource as well as, identifies the resource. That's the ZapThink.com port, and then it also the means of acting upon it, the HTTP part, right? That URL tells me, oh, this is a web-based resource. I use HTTP to access it, and here's how to find it. Now, uniform resource names are a little less familiar. Those don't specify the location, but they're unique identifiers within some sort of naming system. So this is actually the ISBN, that's the international book number for the book that we published 6 years ago, and that's an actual valid URN. So that particular URN, if you were to look it up on Amazon, you would get our book, but it doesn't tell you anything about where the book is located on the internet. It just gives you a unique identifier in the ISBN namespace. So that's essentially URIs come in those two flavors. Okay, so one of the key best practices, and this is if you're a developer and you've been working with REST, this is one of those rules you can break, but you shouldn't. So the key best practice is to follow a RESTful approach to creating these URLs. Now the problem is that if we've been programming for a number of years, we're working in a systems environment, doing integration for a number of years, we tend to fall into this remote procedure call way of thinking about the world, an RPC-based approach, where we're trying to do distributed computing, so we think of that remote piece of software. How do we call it? Well, we call procedures. We think of it as having an API that has particular procedures, and we call those procedures. So the problem there is we have to know a lot about how it works ahead of time, and if we want to change what the server does for us, that might break things, and that's essentially what we mean by being tightly coupled, right? If we change something on the server, it breaks the clients. So an example of an RPC-based URL, it's at the top there, right? I have example.com/cart, that's the name of the resource, and then update cart, cart ID equals 47, right? So I name the operation, update cart, I name the parameter, cart ID, and I give it a value, right? Now I can get that to work, right? If you've programmed on the web, you've probably programmed URLs like this all the time. But the problem is that the client has to know all these details, and the server can't change how it behaves, right? The server's hands are tied, saying, okay, well, I have to support this update cart operation, I have to take cart IDs, 47 has to be a valid cart ID, or I can't do anything with this request. So a RESTful approach, basically get rid of that question mark, get rid of the equal sign, get rid of the name of the operation, right? All I have are get, post, put, and delete. So I do example.com/cart/47. So what does that mean? Well, it's whatever the client expects it to mean, and it's the responsibility of the server to respond appropriately. So if I'm getting that, I send a GET request to that URL. The server has to respond with what the client is expecting, along with all the other operations. So this gives us flexibility, because now if I want to update the server functionality, as long as the server is responding appropriately to these 4 operations, the interactions will continue to work. Okay, so what is a representation, right? It's like a web, think of a web page, well, it could be any kind of media type, any type of internet media type. So that phrase internet media type, you may or not be familiar with it. That's an update of the old term MIME type. Remember MIME types? That was the internet, it was an internet messaging type for email, for email attachments. Well, that's been generalized now. It's now called an internet media type, and it could be any kind of standard representation format. So these are familiar MIME types or internet media types, like text/HTML, text/plain, XML, JSON, etc. And the list goes on. And these are all standard internet media types that are well understood, and your software probably already understands them. And I put these little icons here because this is how a lot of operating systems identify document types, is by the media type. So that's how it knows. So that's a PDF, well, because it has the PDF media type. And so that would give you the right icon. Okay, so now what are hypermedia? Well, remember that what REST is for, it's an architectural style for building distributed hypermedia applications. This is the point of REST, is to build hypermedia applications. Hypermedia is just essentially a word that means a big website where you have many different types of media representations, web pages and image files and any kind of representation you like, and they're interconnected via hyperlinks. So the way you get from one to the other is you follow a hyperlink, and that creates essentially a hypermedia application, which is now an abstraction of a website. So the World Wide Web itself is an example of one of these, but the whole point of REST is that you could build your own hypermedia applications that follow these same best practices, and now you have all these great benefits that the web gives you for your own application. So, when we say architectural style, REST is an architectural style. That phrase architectural style has a specific meaning. What we mean by architectural style is a set of constraints. Right? So we have an architectural approach. We can do all these different things, to do an architecture, all these different rules we might want to follow. But when we say we're doing REST, that means that we're going to follow a particular set of constraints, and that means we're following the architectural style called REST. In the case of REST, we have 4 specific architectural styles: separation of resource from representation, manipulation of resources by representations, self-descriptive messages, and hypermedia as the engine of application state. Now we'll go through each of these in turn, but the point is that you have to follow all 4 of these to be doing REST. Does everybody who say they're doing REST follow all 4? No. If a lot of people follow 1, 2, or 3 of them, saying, well, this is REST, or REST-like, or immature REST, and if it works, if it solves your problem, there's nothing wrong with that. Right? If you're solving the business problem, then you're doing your job, but it may not be REST. To do REST, you have to follow all 4. Okay, so let's go through each of them in turn. Separation of resource from representation. So remember, a resource, think in your minds like a PHP script on a server. A representation is the web page that PHP script might generate for you. Well, if you look at those are different as a rule, right? A whole page of PHP and a page of HTML are different. Right? Now, sometimes they're similar, right? You might have a static file on a server, and you do a get on that, and you get that static file, and it looks just like the file on the server. But generally speaking, resources and representations are different, right? So resources live on the server, and they're responsible for certain things, and representations are what the server gives to the client, and those are responsible for other things. So in particular, the state of resources that's on the server should be invisible to users of the resource. Right? So resource state is something that the server keeps track of for all users. Right? So if I have this inventory management application, and the number of widgets in inventory is something that all users want to know about, that's part of the resource state. How the resource maintains that should be transparent. Right? So if I'm a client, I don't care whether it's a SQL, a database, or a flat file, or whatever. It's up to the server to keep track of that stuff. All I need to know as the client is I can do get, post, put, and delete. And I can follow links to interact with the server. And that's all I need to know as the client. So the resource now provides the limitations, or hides the limitations of the underlying media and technology from the users. So if the user says, well, I really want a JSON file, and the server says, I can't give you a JSON file, then that's all it has to say. It hides all the underlying workings of how that decision is made. The second architectural constraint, manipulation of resources by representations. So the representation, think of the web page as displayed on the client, although it could be any kind of representation. So it could be a video file, it could be an XML file, a vector graphic file, it could be running in a mobile device, it could be running in a browser, it could be running on your refrigerator, who knows, right? It could be anywhere. That representation manipulates the resource. So what do we mean by this? Well, how do you actually submit information to a website? Well, you fill in a form and hit submit, and that does a post. That is how you control the resource. The representation is responsible for that. So the representation essentially contains information as to what the client can do to change the resource. So if you think about a web page, you think about a web form, well, essentially that limits what the client can do to the server, because the web form itself provides certain constraints on what sort of post information can be posted. So that representation essentially constrains or provides contracted information that limits what the client can do to the server. Okay. So the third constraint, we're only up to number 3, self-descriptive messages. So each message, so a message is now the information that contains the representation. So the interactions between the resource and the representation on the client, or vice versa, requests from the client to the server. Each of these messages is essentially self-describing. It has all the metadata within the message that the client and server need to process the message. So, for example, if I'm a resource and I'm giving you a JSON file, I'm going to tell you, hey, this is a JSON file. Right? Or if I'm giving you an XML file that has to conform to a schema, I'll point you to the schema so you can find the schema. Right? So all that information is contained in the message itself, including state information. That's going to be an important part of Atul's discussion a little later this morning, because that information is now going to be part of the message. So this is very different from how we do this with the web services-based SOA. In the web services world, we maintain this sort of metadata external to the message. In the contract, WS policy content or some other place, and we have to go find that metadata in our repository, and that's the only way that clients know how to interact with servers with the web services world, is by looking for that contract metadata external to the message. In the REST-based interaction, the metadata are internal to the message, so the message itself tells you everything you need to know. And this is important, right? Because if the power goes out, and then 10 minutes later it comes back on, and all you have is the message, you still know what to do, because all the information about what to do with the message is in the message itself. So, for example, the message will indicate whether or not it can be cached or not. And this is an important part of scaling hypermedia application. Right? The resource might return some representation that can be cached. Doesn't change very often. So it'll say, hey, you can cache me on some proxy. And now the clients can fetch the cached copy of the representation until it expires from the cache. And the representation should make this explicit. So if you've worked with HTTP, if you built websites over the years, this is familiar. This is built into the HTTP spec. If you know the pragma tag, anybody here know and love the pragma tag in HTTP? That indicates whether or not the web page is cacheable or not. So that's part of the HTTP spec, is a way of indicating in the web page, you can cache me or you can't cache me. Okay, so now we're getting to the good stuff, the fourth constraint. Hypermedia is the engine of application state. This is the one that developers freak out over, right? They get to this one and say, I don't have a clue what this means, so I'm going to punt. I'm not going to even touch this one. The problem is, this is where REST really begins. Because REST is about building hypermedia applications and about transferring application state to the client in the form of representations. Because we have self-descriptive messages, we can put application state information in those messages so that the client can maintain the application state. So our state engine for the application is on the client. So state engines are nothing new. If you have a computer science background, I can sort of tell that you all pretty much do, right? The state engines, right, basically move an application from one state to the next. We want the client to do that for the application state. Now, the server still maintains resource state, but that's state that's shared across all clients. We don't want to share applications, we don't want to put application state on the server because the more clients we have, the more state information we need to maintain. It's not scalable. But if we maintain application state on the client, then the more clients we have, the more applications we have, but every client has their own computer, right? So it's infinitely scalable, right? If we have 100 million clients, how many client computers do we have? We have 100 million, right? So that's where we want to put the application state. So when we say Hypermedia is the engine of application state, we mean we're pushing state information to the client in the form of hyperlinks. So how do we actually run our state engine, right? How do we know how to move from one state to the next? Well, we know because we look at the hyperlinks in the Hypermedia representation. So hyperlinks, you can think of them as very simple as, a link you can click, but of course it could be links that are clicked by computer programs, right? It's not necessarily that a human being is on the client. It could be another piece of software that is running the application for you. So it could be fully automated, but how does the client know